Okay, so here are two different ways of describing reality. Imagine a silly movie where you have two cops. One, you have the slow cop that works by the book. This guy is rigidly organized, loves structure. Scientists call this the finite element method. He likes to take something solid, slice it up into tiny little blocks, and compute how these blocks interact with each other. This guy is great at a simple case, one perpetrator, like simulating solids. But taking care of a chaotic riot, like splashing water or crumbling sand, this guy just can't keep up. Not a chance. He says, yes, we can take care of that. But first, a little paperwork. By the time the paperwork is done, it's too late. So, what do? Of course, we do what every silly cop movie does. We hire another cop. This cop is fast and used to be a criminal. Now, this guy is crazy, okay? He is the loose cannon, doesn't care about paperwork. Probably even shoots a nice little hole through it, okay? He is fast, amazing at taking care of a crazy riot like this. Fluids and sand, no problems. We call this the material point method. However, if you ask him to hold everything together nicely, he falls apart. See how it completely ignored the interaction between the two? Fine geometry plus chaos equals pandemonium. Can't be done by this guy. Now, we have a huge problem. These guys would be the perfect duo. Yes! Wait, no. No, because these guys hate each other. So, in video games, when things try to interact, we get clipping, where solid objects just ghost through each other or explode into infinity because the math breaks. Now, this research work finally gives us a way to get these two guys to work together. Remember this? Well, hold on to your papers, fellow scholars, because it suddenly looks like this. Ooh, finally, chaotic interactions and keeping geometry intact at the same time. Woohoo! Now, let's take a bunch of sand with about 5.5 million particles and wrap it up nicely with a piece of cloth. This is the perfect gift for someone you hate with a passion. Okay, so what happens? The fast cop takes care of the sand particles and the slow cop defines the cloth. And no cheating, no crazy clipping, just two cops working together in harmony. Absolutely loving this. Now, this is crazy because normally these two officers really hate each other. Zero chance of working together. And yet, this work somehow pulls off the impossible. How? I'll tell you in a moment. And I'll note that no AI is required here, only human brilliance. That would be great, because we can even drop a snowball onto these elastic mushrooms or have a wheel imprint itself into granular soil. Absolutely incredible. Just think about every video game and animation movie doing this. Wow. And once again, two worlds collide. They simulate a rolling pin flattening dough. It deforms permanently, while the pin stays rigid. And I absolutely love this massive landslide. Normally, you can simulate the sand particles, but not the interaction with something elastic. Now, check this out. Oh my! The trees are waving, and the interaction leaves these little streaks in the sand at the same time. Ooh. It is an absolute miracle that we can do this. Okay, this used to be impossible, but not anymore. So, how on earth did they do that? Dear fellow scholars, this is 2-Minute Papers with Dr. Károly Zsolnai Fehér. Well, the key idea in this paper is creating a shared bulletin board for the two cops. This allows two fundamentally opposed simulation methods to exchange forces without ever directly touching. And the result is crash-proof physics. How? Well, think of it as a way of communicating between the two cops. The by-the-book guy, the finite element method, is slow and methodical. He needs time to fill out his report. The fast cop, the material point method, is fast and reactive. He makes split-second decisions. If they try to talk at the same time, it would be chaos. So, the researchers created a schedule. The slow officer takes a big, slow step. Now, here's the key. Inside that one big step, the fast cop takes many fast steps. They occasionally update each other only when necessary. Here, they effectively agree to disagree on time, but agree on force. Genius. We can actually look at how this works. Check out this beautiful simulation view. This is like a thermal camera showing which officer is sweating. The blue areas are calm. Zero interaction, low computational cost. Blue means peace. Blue means the two cops don't have to argue and we save a ton of compute. Why? Because everyone is doing what they are good at. But wait, look at the red area. What's going on here? An argument. That's what's happening. So, what happens then? Well, here, the slow cop says to the fast cop, hey, wait a second, let's stop and sync up. You give away a little speed here and get more stability. Okay, now let's put this all together and analyze this scene. Look at this. We have highly viscous honey controlled by the fast cop pouring onto a piece of cloth. This is the slow officer. Normally, this is a crime scene waiting to happen. Why? Because the cloth is only maybe half a millimeter thick. But wait, we know what happens with that. Oh yes, clipping. Usually, the honey particles would just ignore the thin barrier and ghost right through it like it doesn't exist. But here, the slow cop holds the line. There is communication. Look, the cloth actually buckles under the weight of the honey. The honey folds over itself and starts doing my favorite, coiling. Oh my, loving it. And it kinda sticks to the fabric. An absolutely insane simulation. To make these two officers respect a fraction of a millimeter boundary without exploding is a mathematical miracle. Not only that, but this is also excellent life advice. We have two cops here that are good at different things. Neither of them can do everything. And you should also stop trying to be good at everything. Partner with someone who is strong where you are weak. This is what I also do with my wife, Felicia. She is strong exactly at areas where I am weak. That's why we've been able to run this channel for more than 1,000 videos now. Let's be honest, I am the loose cannon here, and I need someone that makes sure the papers lab does not work like a mental asylum. And it works beautifully. She even gave me this nice white jacket, and my lunch slides in under the door. What's not to like? Now, all this means we can finally simulate movie-quality destruction in one unified system. What a time to be alive! Now, on a more serious note, this is an absolutely beautifully written research paper, and I see absolutely nobody talking about this. I kind of understand. I mean, it is a really advanced work in physics simulations. But I am worried that if I don't talk about it here, no one else talks about it. And this thing is a treasure. Subscribe, hit the bell, and leave a kind comment if you enjoyed this. And make sure to sign up for Lambda because they give you these amazing GPUs to run simulations and anything else on. And they support us in creating these super fun videos for you. Here you see me running the full DeepSeek AI model through Lambda GPU Cloud. 671 billion parameters. Running super fast and super reliably. This is insane. I love it. And I use it on a regular basis. Lambda provides you with powerful NVIDIA GPUs to run your own chatbots and experiments. Seriously, try it out now at lambda.ai/papers or click the link in the description.